Okay, so this video is about the 5 types of reactions, and you will need this worksheet to do your notes for this video. So after you've located that, then press the start again. Okay, so the first kind that we're going to talk about is synthesis. And in synthesis, you have 2 or more substances for reactants and 1 product. Synthesis means to make. So, like a synthesizer makes music. So, you get one thing, one brand new thing. And that's going to be the important part. So, the general equation is going to be A plus X yields AX. 2 things come together. It can be more than 2, could be like 3 things make 1, but that's going to be your general equation. And so, here's an example. The magnesium and the oxygen come together, and now you have magnesium oxide. And they got to worry about those charges. So magnesium's 2 plus, oxide's 2 minus, sorry, 2 minus. So 2 plus and 2 minus, you just write down MgO. And that's how you get that equation. All right, so then the next kind is decomposition. Decomposition is the opposite of synthesis. We're going to start with 1 compound and make 2 or more new substances. So break it apart, decompose like a body decomposes after uh, a living thing dies. So break it down. Take 1, break it apart. So it's going to look just the opposite of that synthesis equation. So AX yields A plus X. And an example of that is this equation where we're breaking down water into hydrogen and oxygen. And a reminder, hydrogen and oxygen are both diatomic molecules. So we start out with the hydrogen and oxygen bonded together, and then we break them apart. Right? Then the next kind is single replacement. For a single replacement reaction, you're going to start and end with an element and a compound. Right, so start with an element and a compound, end with an element and a compound, but of course they're going to change. And so when you do the general equation over here, I need you to leave space for 2 different equations. So the first equation we're going to write here at the top. Okay, wait, click, let's try this again. There we go. A plus bx yields b plus ax. So the A is going to go into where the B is, and the B gets kicked out. All right, so what does that look like as an equation? Here is one equation. We did this in the lab, zinc and hydrochloric acid. And so the zinc comes here and it kicks out the hydrogen. It replaces the hydrogen. When you're writing these equations, you've got to remember things like the hydrogen is diatomic, zinc has a 2 plus charge, that's on your ion list, and the chloride is 1 minus. You got to crisscross to get ZnCl2. All right, so that's what your example is. Double replacement is the next kind, and oh wait, sorry, let's go back. The other equation is you can replace the back of the equation. So here we have y replacing the x. It kicks the x out, so the x is by itself, and now the b is with the y. You can replace the front or the back. Okay, now that double replacement reaction, you're going to have 2 compounds that exchange their parts. So you get 2 different compounds. Right, so when you do this, it looks like this. So AX plus BY yields AY plus BX. And then that's the general equation. That's the general equation. And let's look at what's happening. The A goes, it's kind of like square dancing. The A is going to go with the Y and the B is going to go with the X. Make sure that the cation stays in front and the anion in back. And let's take a closer look at that example. So here it is. We have the potassiums going in where the lead was, and the lead's going over here where the potassium is. And when you make these compounds, you have to always check those ions. Double replacement. 2 things are being replaced. And then the last kind is combustion. And in combustion, you're going to have some substance plus oxygen, right? So over here in the general equation, it says plus O2. That's what you have to have, O2 over here. And you get oxides out of it, and light and heat in a combustion reaction. So here's an example. You can burn hydrogen. It's what we use in a hydrogen fuel cell. This is a explosive reaction, the Hindenburg. You might want to look that up, the Hindenburg reaction, where the Hindenburg caught on fire because it was filled with hydrogen. And so we get water, which is the oxide of hydrogen. And if you look up that film about the Hindenburg, you will see that there was lots of flame and heat also. All right, now what I've done in this slide is highlight the important parts that help you tell one from the other. So you want to go back and highlight or circle them or underline them, do something with them. So a synthesis, how do you know that? It's a synthesis reaction when there's only one product. So here it is, one product. This one has two, this one has two, this one has two. The oxides are going to have some more. This could be a synthesis reaction because there's only one product. This could be a combustion reaction because we're adding the O2. And so you got to watch out for that. In decomposition, there's only one compound for the reactants. So right here, two reactants. Here's the only one with one reactant. Two reactants, two reactants, two reactants. There's only one reactant here. It has to be decomposition. Single replacement is always going to be an element and a compound. Gives you an element and a compound. Right? You always have an element and a compound on both sides. Double replacement, you're going to have two compounds on both sides. Exactly two, by the way, not three, not four on any side, two. And then for combustion, you're looking for this O2, this oxygen in the reactants. All right, and then you're going to need to add these to the back or wherever this is. Put it on the back. A hydrocarbon is a compound made out of only hydrogen and carbon. And so that's what that is. It has the combustion of a hydrocarbon always gives you the products of carbon dioxide and water every time. So I give you this is the simplest hydrocarbon down here. One carbon, four hydrogen. You add oxygen, you get carbon dioxide and water. You could have two carbons and eight hydrogens, and you'd still get carbon dioxide and water. You could have 10 carbons and 44 hydrogen. You'd still get carbon dioxide and water for the products every time. So the products are always carbon dioxide and water when you burn a hydrocarbon. Okay, so that's it for the notes. You can go back and watch this. I know it comes fast, but that's what the pause button is for. So see you at school. Nope, that didn't work.